In video 17, I suggested I might look at an alternative power supply for the RoboRaptor models, toys or whatever you want to call them, that I'd been playing around with. Just a quick word of warning, don't try and replicate anything in this video. Lithium cells can be quite dangerous and there's a possibility of a fire, possible injury if you manage to short circuit these cells. So I advise you not to do this. It's an educational video just for interest only. So just as a bit of a reminder, this is what I was looking at in video 17 in terms of the existing power supply. As you can see, we've got 3 volts out to what I believe is the infrared detectors and 6 volts out to the motors. The thermal fuse, now let's have a look at the specs of the thermal fuse. Let's zoom in on those a little bit. The thermal fuse we're using is the GK30135, and as you can see that's a current of 1.35 amps with a maximum current of 6.75 amps for 8 seconds at 30 volts, and that's when it's going to blow. So it's not designed to hold a whole lot of current. This is the alternative solution that I've theorized might work. I'm going to use a couple of buck converters to drop the voltage from some LiPos, from 7.4 volt LiPos, which can go up to about 8.4 volts, down to 3 volts and a 6 volt supply. This is the original battery configuration, plugged into one of the RoboRaptors, and as you can see, it's 18.3 millimeters in depth. Why is that important? Because there's a belly plate that screws into that. We don't want to go much beyond that, otherwise we're going to end up taking bits out of the belly plate. Now this is one of the 18650 battery holders that I've got. And this is for 2 cells side by side. They're not wired in any particular way, and they come out at 18.8 millimeters, which is pretty close. And this is an alternative one. Now these are wired up so the 2 cells are in series, which is what we want. They're fairly secure, and they're only slightly thicker at 20.2 millimeters. We've got these little buck converters. These are adjustable ones. You can adjust them with a little screw that you can see there, and they'll easily handle the 7.4 volts in, and they're just an in and out, and adjust the output voltage with a little tiny pot that you saw on the top. This is a 6 volt UBEC. They're used for radio controlled models, usually for video in the quads and that sort of thing. Selectable between 5 and 6 volts, and this will handle a maximum of 6 amps, 3 amps steady, and as you can usually only pull about 2 amps from a AA cell. I'm not overly worried. I jury rigged up my concept circuit, plugged it into a RoboRaptor, and these are the results. Now I can promise you I didn't intend that to happen. It was quite amusing. Looked like the 2 RoboRaptors were having a bit of a tiff. You will have noticed that the RoboRaptor, the donor Raptor, that I'd pulled all the bits off, the one nearest to the camera seemed a little bit more lively, and that's because it was running on 6 volts. The Raptor further away was running on AA cells, and they'd been used a little bit, so they were probably down from the 1.5 volt peak because they drop off quite rapidly. And that's one of the advantages of using this particular setup. There's no protection for the LiPo batteries. It probably isn't needed because once the cells drop below 6 volts, the UBEC supplying the 6 volts will stop working. It needs a higher voltage input than it actually gives out. So that will stop the cells being overly drained. What I didn't like was that both buck circuits are energized when the Raptor is switched off. You can see that from the glowing LED. So I probably need to rejig the on-off switch to make it work a little bit better. Anyway, I hope you found that interesting. Cheers.